Okay, these are the notes for section 7.1 in Algebra 2 on roots and radical expressions. So all of chapter 7 is simplifying radicals, solving equations with radicals. So first we just need to learn what a radical is. So a radical is the symbol that we use to take a square root or a cube root or a fourth root. Most of the time we're used to seeing a square root and there's not an index on the outside. There's no little number there. If there is a number there, for example, a 3, that would be the cube root. If there was a 4, that would be the fourth root. So that number tells us how many factors we need of the number underneath, which is the radicat. Okay, so let's look at how to simplify radicals. So we're going to start by finding the real square root. So two things before we get started on the examples is first it says real, okay? So we're not talking about imaginary numbers. There's not going to be any i's in our answers. We're talking about real numbers. Second thing is it wants a square root. So a square root tells me that we need two numbers that multiply to equal our number that they're going to give us, okay? And we're going to simplify as much as possible. So our first number that we want to find the square root of is 49. So if you can't think of what number multiplies to get 49, then you want to factor that number out. And I'm going to use the L method. So I know that 7 goes into 49 7 times, and I can't factor it any further. 7 and 7 are both prime numbers. Since this is the square root, we need a pair of numbers, two numbers that multiply to equal 49. So our pair of numbers is the only two that we have, 7. So anytime you're simplifying a square root, that pair of numbers is going to come outside of the radical. Any leftover numbers would stay inside if they didn't have a pair. But since we just have a pair of 7s, our answer is going to be 7. But not only 7, it's going to be positive or negative 7. Because I can do positive 7 times positive 7 to equal 49. I can do negative 7 times negative 7 to equal 49. So we're taking the real square root of a number. We're going to put positive or negative of that number in front. Okay, so now we're going to look at the number 27. So I don't know of two numbers that multiply to equal 27. It's not a perfect square, so let's factor it out. So the smallest number that goes into 27 is 3, and I know that 3 goes into 27 9 times. And then 3 goes into 9 3 times also. So I've factored completely. Everything on the outside of our L method here is prime numbers. Since this is a square root, I'm looking for a pair of numbers. So I have a pair of 3's here. This pair can come outside of the radical, and the leftover 3 is going to have to stay inside because it doesn't have a pair to go with it. So this is going to be positive or negative 3 from the pair, and then I have a square root of the 3 left over inside. So this is plus or minus 3 square root 3. Okay, now we're going to do negative 100. So I need two numbers that multiply to equal negative 100. Well, I know 10 times 10 is a positive 100. And then negative 10 times negative 10 is a positive 100. But I can't do negative 10 times positive 10 because those are two different numbers. So for this situation, there isn't a number that multiplies by itself to equal negative 100. So anytime we're trying to take the square root of a negative number, the answer is going to be no real number or no real solution, however you want to say it. But it's just not a real number. If you remember in a previous chapter when you learned about imaginary numbers, when you took the square root of a negative number, you pulled an I outside of that square root for imaginary. So here, we're not going to do imaginary numbers, we're talking about real numbers only. So there's not a real number that multiplies to equal negative 100. Okay, let's try 75. So I can't think of anything that multiplies to get 75, so let's factor it out. So I know that 5 goes into 75 15 times, and then 5 goes into 15 3 times. And it doesn't matter what order you factor. You could have started with dividing by 3 first. Eventually we would have gotten the same factors. It doesn't matter the order. So I circle my pairs. Pairs of a number get to come outside. Any leftovers stay inside. So my pair of 5 comes out, so that's plus or minus 5, and then my leftover 3 has to stay inside the radical. So this is plus or minus 5 square root 3. Okay, number 2, we're going to be finding the real cube root. So again, real numbers only, no imaginary numbers. And a cube root is looking for not a pair of numbers, but 3 of a number. Cube means 3. So we're going to start with 64. So if I factor 64, I know that 2 goes into 64 32 times. And I know 2 goes into 32 16 times, and 2 goes into 16 8 times, 2 goes into 8 4 times, and then 2 times 2. So when you're factoring, keep in mind you want prime numbers on the outside and factor out as much as you can. So since it's the cube root, I'm looking for triples of a number, sets of 3. So here's a set of 3, and then here's another set of 3. And looks like I'm not going to have any leftovers for this one. So each set is going to come outside of the radical as one of those numbers. So that's going to be 2 from the first set and another 2 from the second set. So 2 times 2 is 4. Now because this is the cube root, we're not going to put a plus or minus. We're only going to put plus or minus if we are taking an even root. An even root would be the square root, the 4th root, the 6th root, etc. Whenever you're taking an odd root, 3rd, 5th, 7th, etc., you don't put a plus or minus. Okay, so now we're going to do negative 1 over 27. And I know we sometimes panic when we see fractions, but we're going to treat the fractions as 2 separate numbers. We're going to take the cubed root of the top and then take the cubed root of the bottom. So I want to do the cubed root of negative 1 over the cubed root of 27. So if I think about negative 1, something times itself 3 times that would equal negative 1, well that's just negative 1. Negative 1 times negative 1 times negative 1 equals negative 1. And then I need to take the cubed root of 27. So something times itself that will equal 27. So 3 times 3 times 3. We factored it out earlier. So the cubed root of negative 1 over 27 is just negative 1 over 3. Take the cubed root of each piece and then just write your answer. Okay, now we're going to do 375. So let's factor 375. So I know that 5 goes into 375 75 times. And then 5 goes into 75 15 times, and 5 goes into 15 3 times. You're going to notice we're going to use a lot of the same numbers over and over again. It's just easy to use those numbers. So this time I'm looking for a cube root, so I need a triple. So there's a triple of 5s. So they get to come outside as 1, and then any leftovers stay inside. So this is going to be 5 times the cubed root of 3. Make sure you put the little 3 for the index to tell people that it's the cube root and not a square root. If there's not a number there, it's understood to be a square root. Okay, so 5 times the cubed root of 3. Okay, now we're going to try the real 4th root. So 4th root means 4, so we're going to be looking for sets of 4 after we factor. So we're going to start with 16 over 81. So again, don't panic because it's a fraction. We're going to take the 4th root of the top and the 4th root of the bottom, and then we'll simplify if we need to. So let's factor 16. So I know that 2 goes into 16 8 times, 2 into 8 4, and then 2 and 2. Since this is the 4th root, I'm looking for groups of 4. So that's perfect. I have all the 4s, or all the 2s are in a set of 4. So plus or minus 2 for the top. Then let's factor the bottom. 81. So I'm going to divide by 3. 3 goes into 81 27 times, 3 into 27 9 times, and then 3 and 3. So, look again, we have a set of 4. Perfect. So those 3's come outside as 1 and they go on the bottom. And remember I put plus or minus 2/3 because this is a fourth root. And for an even root, it could be a positive or negative answer. Okay, now we're going to try negative 625. So this is an even root of a negative number. And remember, we can't take the even root of a negative number. This is not going to be a real number. There's nothing times itself that's going to multiply to equal negative 625 because it's an even root. So you're just going to say no real number. Okay, let's try 10,000. So I could sit here and start with 2's and factor this all the way out. It's going to take a little bit of time if I start with 2's. So I'm going to start with 10. So 10 goes into 10,000 1,000 times. 10 goes into 1,000 100 times. And 10 into 100 10 times. And look at that. For the fourth root, I'm looking for a set of 4's. So this is just going to be plus or minus 10. Okay, so on example 4, this is just going to be a mix-up of different roots that we're going to simplify. For the rest of these problems, we're not going to put a plus or minus sign. Because the radical is already on these problems, there's no need for a plus or minus. The previous problems didn't have the radical there. We were just finding whatever root they asked for. We needed to put a plus or minus for those even roots. But for the rest of these examples, it's not necessary. So, A, the square root of 81. So you may know what the square root of 81 is. You may have that memorized. If not, factor it out. I know that 3 goes into 81 27 times, 3 into 27 9 times, and then 3 times 3. Because this is a square root, there's an understood 2 that's outside of that radical. I'm looking for pairs of numbers. So I have 2 pairs of 3's. So that's 3 times 3, which is 9. And if you have your perfect squares memorized, you know that 9 times 9 is 81. So the square root of 81 is 9. Okay, let's try negative cube root of 27. So this negative is not part of the radical. It's not underneath there. It's like if there's a negative 1 times whatever the cubed root of 27 is. So we're going to simplify the cube root of 27, then we'll multiply whatever we get times that negative in the end. So if I factor 27, I know 3 goes into 27 9 times, and then 3 times 3. So since this is a cube root, I'm looking for a set of 3. So perfect, I don't have any leftovers. So this set of 3 is going to come outside of the radical and multiply times anything that's already there, which is that negative 1. And since we don't have any leftovers, there's not a cube root anymore. So this is just negative 3. Okay, so let's try the square root of negative 64. So remember, when it's an even root, if it's a 2, a 4, a 6, and an 8, we cannot take an even root of a negative number. It's not a real number. So you're just going to say no real number, and you're done. Okay, now we're just going to simplify. So we're going to throw in some variables here with different numbers and simplifying those radicals. So let's start with the square root of 90x squared y to the 5th. So we're going to treat each piece that's underneath the radical separately, and then we'll simplify it and make it look nice and neat at the end. So let's start with 90. So I want to factor 90. I know that 3 goes into 90 30 times, and 3 into 30 10 times, 2 into 10 5 times. So everything on the outside is a prime number, cannot be divided out any further. So since it's a square root, I'm looking for pairs. I have a pair of 3's and then a leftover 2 and a 5. So those 3's get to come outside. The 2 and the 5 have to stay inside, but they're together, so it's 2 times 5, which is the square root of 10. Now let's do the variables. So when I'm doing variables, I think of it this way. Since this is a square root, I think 2 goes into 2 how many times for the x's? Well, I know 2 goes into 2 one time. So that's going to be an x to the first power that gets to come outside. Then for the y's, 2 into 5. Well, I know 2 will go into 5 2 times evenly, and then I have 1 remainder. So the y squared gets to come outside, but that 1 remainder has to stay inside. So to simplify this problem, I would just drop the 1 exponents. So I would just say 3xy squared times the square root of 10y. Okay, so let's try the cubed root of 32x y to the 6th z to the 5th. So let's factor 32. I know that 2 goes into 32 16 times, 2 into 16 8 times, and 2 into 8 4 times, then 2 times 2. So it's completely factored. Since it's the cube root, I'm looking for sets of 3. So I have a set of 3, and then I have 2 leftovers. So the first set can get to come outside, and then the leftovers have to multiply and they stay inside. And so remember, it's the cubed root here, so you have to put that little 3 there. Now let's do the variables. So cubed root, I want to see how many times does 3 go into 1. That's an x to the first power. Well, 3 doesn't go into 1, so that's 0 times, so that x has to stay inside the radical. Okay, then for the y's, 3 into 6 goes 2 times and no leftovers. So that's a y squared on the outside. Okay, then 3 into 5 goes 1 time evenly with 2 leftovers. So that's going to be a z to the first on the outside and a z squared on the inside. Okay, so if you wanted to simplify this, you could just drop the 1 for the z on the outside. 2y squared z times the cubed root of 4xz squared. Okay, last one, the fifth root of 5x squared y to the 5th. So, if I factor 5, 5 is just 1 times 5. So there's not anything that I can factor 5 into to be able to find a fifth root. So that 5 is going to have to stay inside. Then I look at my x's. 5 into 2. 5 doesn't go into 2, so x squared is going to have to stay on the inside. Then for the y's, 5 into 5 goes 1 time, so that's a y to the first on the outside. So this is just y times the fifth root of 5x squared.